My clock just turned 3 p.m. So I cordially welcome you here from Winterthur, wherever you are in the world. Good morning, good afternoon, or good evening. And we are recording this event, so recording already started. If you don't want to be recorded, just let your camera switched off. And if you would like to post a question, put it in the chat so we can read it aloud and you won't be in the recording. So there's already one in the chat. Good afternoon. Okay. Now I did something wrong here. Sorry. Opened the chat and didn't know how to switch it off again. So hello everybody, and most of you will know me. I acted as chair for the last IPrA conference, Christiane Hohenstein, and I'm now part of the education and outreach team of IPrA. We are organizing the webinars, which are linked to the mentorship, mentoring program from IPrA. And these webinars are actually aimed at early career scholars, but open to everyone who is interested. And we discussed which would be good topics for these webinars. So we came up with the idea that both topics and fields which are interesting for career management in pragmatics, for career development, as well as content on methods in pragmatics and things like that would be good, good topics for webinars. So this, our second webinar, is dedicated to methods in pragmatics. And since we have both quantitative and qualitative methods, quite a few of them in pragmatics in our approaches, and most of us combine these approaches probably nowadays, we thought it would be good to show an approach and research questions and the way to tackle research questions with both qualitative and quantitative methods. An approach which is linked to both corpus linguistics and discourse linguistics. So I introduce today to you, and I'm very happy to welcome here as our speakers, Professor Philipp Dresen and Klaus Rottenhäusler. Philipp Dresen is a professor of digital linguistics here at Zurich University of Applied Sciences in our School of Applied Linguistics. And he specifically works with the Swiss-AL-Workbench, which means AL is for Applied Linguistics, Angewandte Linguistik in German, so it's the same letters. And it's the largest Swiss database with texts in all the languages, the official languages of Switzerland, which is German, French, Italian, and Rito-Romanian. So they will be talking about the SwissAL-Workbench and what can be done with it. And they will also talk about the way it is linked to other approaches in digital linguistics. And maybe I shouldn't say any more here. The floor is now open for the input from Philipp and Klaus. And afterwards, we will have time enough for a discussion session. And if you don't want to switch your camera on, you can put your question in the chat and I will be reading it. And I hope I will see the hands raised in the discussion session and try to moderate. Okay, so Philipp and Klaus.
Thank you. Yeah, thanks for your nice introduction and also very warm welcome from our side. I will share my screen. Does it work?
Yep.
Yes.
Okay. Yes, we want to talk about qualitative versus quantitative methods, an approach to qualitative questions in applied linguistics using the Swiss-AL Workbench. And we would like to start with some words about us, what we do and what we not do. We are from the digital linguistics and do discourse analysis. So we use corpus-based and corpus-driven approaches, but we also use qualitative methods. And maybe this is a reason why we are choosing for this talk. We are also working in the context of multilingual discourse analysis, and this is quite new, this network of comparative discourse study. This is founded last year. We would like to suggest the following outline. We would like to start with some ideas on qualitative research questions and quantitative approaches. Then you would like to introduce the SwissAL Workbench. We'll have a look at 3 examples that deals with this qualitative research question and quantitative approaches. And finally, we want to have an outlook on the transformation of the SwissAL Workbench into an ORD, so Open Research Data platform for applied sciences. You may know that the ultimate answer of all questions is 42. And maybe you know this sentence. It's from The Hitchhiker's Guide, a very famous book by Douglas Adams. And maybe this is some aspect that is always discussed in context of corpus linguistics, that there's also a result, but always, or not always, there's a reasonable way of interpretation of what is offered by the computer. So a statistic or a number or a graph or something else. And we think Adams put this into this book in a very nice way. Because he denied the research question. So what is the answer? What is the question? The answer is 42. And the question for all of the approaches in corpus linguistics and computer linguistics is always, how can a statistic or a number or a graph can be interpreted in terms of a qualitative research question? That is always in the beginning of research in especially pragmatics and also discourse analysis. So some of our colleagues would say there's a tension between quantitative and qualitative approaches. Some would say there's a possibility to do a mixed method approach. Maybe you know the term triangulation. That means a triangulation of theories, of data, of methods, and also of researchers in a team with different knowledge base and ideas. And what we would like to talk about is there a third possibility to think about quantitative and qualitative approaches. We would like to present the following idea. So we have a qualitative research question, and we use quantitative data and methods, but we have result from our quantitative analysis, and we are forced to do an interpretation, so qualitative interpretation of these results to get a final answer. And to keep this in mind, we would like to present you our examples that may are useful for your pragmatic research. So what is SwissAL? A short overview. Swiss Applied Linguistics is a multilingual language data resource of especially Swiss public communication that allows for data-driven analysis and simulating of social discourse. As a language data resource, the corpus consists of a family of multilingual Swiss public communication corpora, but also of a computational linguistic pipeline to proceed the language data and to put it on the browser-based workbench for analyzing these corpora. Now we have a very short ad block. We are part of Clarin. If you are from Europe, you may know this. Clarin is a common language resource and technology infrastructure. It's a pan-European association of 33 countries, and these countries try to support social science and humanities that want to use language data on a with a very low threshold. And Switzerland joined this association in this year, and now there's a new network called Clarin CH, and our university is part of it. In the corpus, SwissAL, this is a family of corpora. That means we have 3 big subcorpora. The first is SwissAL Media. This is from the Swiss Media Database. We have journalistic media in all 4 official languages. Then we have maybe the core or the USP of our corpus. This is SwissAL Base. We crawl the websites of politics and administration every day, from science, industry, civil society, and also we put the journalistic media in the base corpus. So we are able to monitor the public discourses in Switzerland. What is Switzerland concerned about, speak about, and how actors are shaped by language use in public discourses. And finally, we have SwissAL projects, and this is a subcorpus that consists of corpora we use for specific projects. For example, if we do monitoring of right-wing websites from Germany, then this will be part of SwissAL projects. A few numbers. See the first row, the base corpus of Swiss German media. And then you see the corpus of politics, industry, civil society, and science for German, and then for French and Italian and so on. I would like to hand over to Klaus, who will explain you the pipeline.
Yeah, I'm a computational linguist, and I'm in part responsible for the technical stuff we do at the Institute. And I spend quite a lot of time maintaining or improving our processing pipeline, which we use to enhance the raw textual data we get with additional linguistic information. Until 2 years ago, the workflow always looked as depicted here in the diagram. But then 2 years ago, a nationwide deal was struck between academia and the archival organization of almost all Swiss media outlets, the SMD. And so now we can, or people in academia can access for research purposes almost all the media texts produced in Switzerland. This is a huge relief, and it really helped us improve our corpora. But still, as Philip mentioned, part of our corpora are web-based, so we collect virtually data in any format we get on the web and save it to disk first of all, and then there is the tedious step of text extraction. You have to scrape the data, so you have to really filter out the textual parts that are of interest, and this has to be done manually because all websites are structured differently. Once that is done, it is saved in an Elasticsearch index. Elasticsearch is a search engine, so like a search engine, you know, from the internet, with a bit more sophisticated querying possibilities. We use it mainly as a database, but sometimes the querying possibilities are important if we want to narrowly define which documents become part of corpus. A very important step after we save the text is to remove duplicates or duplicates, especially if you scrape data from the web. You always have very similar or even identical versions of text there, texts that have been edited or texts that appear on different websites and are just slightly modified. And this is another very important step to improve the quality of the corpora, because it's very annoying if you get the same hit if you do a search for some word, and then you get 10 different texts with practically the same item. So only after this deduplication has been done, we proceed with linguistic processing, and there we add standard linguistic annotations, so part of speech tags, and we do lemmatization. So each word that occurs is mapped to a lexicon entry. We also do named entity recognition for identifying names of 4 different categories. So we identify them and we classify them. And for some more sophisticated projects, we also do parsing. We use a dependency grammar framework for that, so it's not a constituent-based framework. There are no non-terminal nodes, just nodes between individual words. But this is an expensive step, so we do it only for smaller corpora, and then there are some language-specific annotations, especially for German, because most of the data we deal with is German. And finally, we put all the process data into the corpus workbench, which is a tool which makes it possible to query any kind of linguistic annotations in the data. Yeah, that's more or less the pipeline we use.
Okay, thanks. And a few words concerning the workbench. There are 2 possibilities to get access from outside. There's a public workbench. However, if there are more than 20 people using this public workbench, we are afraid that our server will crash, and also for software license problems. So we will give you the link in the chat after our talk, and then you will get access to the workbench. The workbench has on the left-hand side several options to do analysis. So you choose a corpus, then you have a quick view, so keyword and context, or you will do a corpus query. You may know TCP Web, for example. Our workbench is working based on this corpus workbench. And there are different types of analysis like distribution or n-grams or keyword analysis, and also, for example, topic modeling. So, for example, you see a bar plot of a distribution over time. This is a bar plot of search term, and this is a visualization of topics within the corpus. So that also linguists who are not corpus linguists can use statistical approaches and can interpret these results with their competences. Okay, then I'll start with the first example, and we'll talk about the problem maybe, or the qualitative of identity. So maybe you have the research question: how are personal identities constituted or constructed in language use? And as linguists from Pragmatic, you know, for example, a sentence like, "Dad, where are my shoes?" So we can say the speaker has the identity of a child related to the father. Or the second example, "I love you," maybe with the relationship of the speaker to the addressed person. There's a kind of relationship and also a kind of identity constituted through language use. Or very simple example, when I state I am a linguist. And what we try to show you is that we can search for that kind of identity also with a corpus method. For example, these are comments from Facebook on elections in UK from 2017. And this is just a random view in the corpus. And I searched for a specific pattern of language use, the pattern as AX. So we are searching for the word as and a specific difference between as and, oh, there's a typo I see. But we are searching for expression like "as a Labour voter," for example, you see on the first line. And it's simple to see that this pattern of language use is not a single one. So there's only one person who uses as a and then a Labour or person or teacher or something else. We see patterns also that work with former. So as a Labour voter, I would vote. As a Labour voter, I want to, and more than this. And we see in the second table, as a former Green voter, as a former fisherman, as a former Conservative voter, as a former communist, and so on. And this is an example from English corpus, but we see this type of pattern also in German. For example, we have an online forum of a German public broadcaster, and they are interested in how so citizens, are criticizing the German public broadcaster, or what the citizens want to see or want to listen to from the German public broadcaster. So in this corpus, we see also this construction, me as, so in German, ich als X. For example, the first sentence, I can only speak as a blind user for the corresponding group of people, or, but I'm not greeted personally as a viewer, or as a man, run our family household about, and so on. Or as a viewer, you feel treated like, and so on. So we see this is a pattern that is used in different contexts. And what's now interesting from our perspective of a qualitative research question, and this more or less quantitative approach, is that we can interpret the results from the corpus in a qualitative way. So we want to do a qualitative coding and interpretation of the results to find distinct discursive formations of identities. So you see, as an example on the left-hand side, als Frau, as a woman, als Zuschauer, as a viewer, as Behinderte, as a handicapped. And we can do a qualitative coding to find identities of persons and social groups, and we can count to them, and we see most of these identities are linked to audience or to political. So me as a conservative person or profession, me as a teacher or age, me as a 30-year-old, and so on. And with this change from qualitative research question with quantitative methods, and again in a qualitative interpretation, we think it is possible to find results concerning identity, not only with a pen and pencil approach, but also with the power of corpora. The second example, topic. The very big research question, what is a talk, a novel, a meeting, or discourse about? Maybe you're concerned with this question when you are trying to get the perfect data for your research. So you ask yourself, if this data is linked to my research question, so is it the same topic? And this raises a big question, what is aboutness and what is a topic? This is a philosophical question, a philological question, a linguistic question, and nowadays also questions in computer linguistics. We can have a look at this example and can ask, what is the topic, or what are these topics of this text? Canada's response to COVID-19 is based on the latest scientific evidence. As we learn more about this illness, we must adapt our public health measures and our border measures appropriately. These new requirements for travelers are part of our multi-layered pan-Canadian response to this epidemic, will continue, and so on. And we will, could you switch your microphone off, please? Thanks. We can ask now, is this a text about COVID-19? Is it about scientific evidence? Is it about measures or border measures? Is it about travelers? Is it about Canada? And maybe all of these aspects are important to find what are the topic of the text. And a very simple idea to find what's the topic of the text is to see what's the title. And we see the title is Government of Canada updates mandatory requirement for travelers entering Canada. So the focus of the text is the measures of travelers and border. However, there are also another part of topics in this text, and this will be explained by Klaus.
Yeah, well, the topic modeling technique has a very strict definition of topics. So, well, topic modeling, first of all, is a machine learning technique. So the computer is supposed to learn something from the data it is presented with. And a bit more precisely, it is an unsupervised machine learning method. So you don't need labeled training data, you just feed the machine with plain text. And the expected result of topic modeling would be a blueprint of the thematic structure of a text collection in the form of a number of topics. These so-called topics are defined in the algorithm as probability distributions over the corpus vocabulary. So every topic basically contains all words, but they have very different probabilities of occurring in different topics. The algorithm models text production as a probabilistic process, which I will briefly present on the next slide, just the rationale. It is based on the original publication from Bly, who coined it latent Dirichlet allocation, or LDA in short, which has something to do with a specific form of probability distributions employed. So the generative process underlying the LDA model looks like depicted here. It assumes you start from a predefined set of topics as seen on the left. And the first thing you do is to choose a distribution over the topics as illustrated by the histogram on the right. So in this case, you would choose, Philip, can you maybe briefly hover over the histogram on the right? Yeah, so everybody knows what I'm talking about. So in this case, you would choose the light red evolution topic to some degree, a lot from the yellow genetics topic, and also some part of the data science topic. You might sprinkle in a bit of brain, but that doesn't seem to be strictly necessary for life. With this distribution over topics, you then go on to choose words one by one. And for each word, you first choose one of the three topics. And based on that choice, you get a probability for each word to be emitted. What the algorithm is actually doing in the training phase is adjusting all the probability distributions at play in the model. This is accomplished by following the generative process backwards. So the algorithm starts from the output, the produced text, and makes an informed guess from co-occurrences of words within documents about their probability of belonging to the same topic. One of the shortcomings you may have noticed is that the number of topics is predefined, and this is, of course, difficult to determine. With huge amounts of text, it is definitely impossible to come up with a perfect number of topics in advance. So can you switch to the next slide? So ideally, you run the algorithm with a range of different values for the number of topics and then choose the best result. There are some metrics which try to capture the quality of the produced topics and might save some work for you. So in this case, I trained a model for values between, or I trained several models for values between 20 and 500 topics. And the metric suggests that at around 150 topics, there is a peak, and afterwards the topic distribution deteriorates again. So we would start by looking at the model with 150 topics and see if we're happy with the results. Unfortunately, the computation of topic models is quite resource hungry. So covering all the parameter space is usually not feasible. I tried to compute models for a 1 billion word corpus for today, and I started on Monday, and still not all computations are finished. So, and the machine is huge. It's at least 10 desktop computers, and it's happily computing still. Anyway, you somehow have to choose, and what you get out of the algorithm, one thing you get out is a visualization of the topics, which is on the next slide. You can see on the next slide. It's actually interactive, but I couldn't embed HTML into the slides, so you just have to have a look at it like this. It's good to play around with the result a bit, but in the end, if you really want to work with the model, you have to have a look at the topics by way of their most prominent words, which you can see on the next slide. So these are some of the topics that were computed. This is a corpus. This is actually the 1 billion word corpus with media texts from English media texts from all over the world during the COVID pandemic. And I think the topics are more or less crisp. The first one, which was highlighted before, the 0 topic, so in the left column, you see the topic ID, and then in the right column, you see the words which are most prominent. The 0 topic is something like academic career topic, and then the ones which are highlighted here cover some country or geographic region. So topic number 1 would be about Asian countries, and yeah, then Philippines, Ireland, New Zealand, South Africa. So they all cover some specific country. Next slide, please. There are topics which deal with some specific aspect of COVID. So 41 would be about masks, and 37 about infection rates, and 29 about measures taken in Europe. 21, I believe, sorry, my screen left me. Okay. Yeah, 21, I think, is about the UK. It has party COVID and prime minister in it. That sounds very much like UK. Next slide, please. There are also completely unrelated topics unrelated to COVID. So this would be about popular culture, for example. And on the next slide, that is a topic about being female, I'd say. So I just try to give some kind of label to them. And there is another topic seen on the next slide, which seems to be about being male. It's interesting to see how they differ. And what is also interesting, if you have a look at topic 0 again, it has also the topic about academic career. It also has his as one of its most prominent words. Actually, this was a mistake I made. I wanted to remove stop words, but I chose the wrong stop word list. I chose the German one. So it stayed in there, and I sometimes feel reluctant to remove stop words, and I think this is really a good example that it makes sense to leave them in, because without this his, an important aspect of the academic career topic would be undiscernible. Next slide, please. the last one, you can also find data flows with topic modeling. So topic 32 just contains technical, or it's based on errors which happened during the scraping of the data. So this is just navigational or technical parts of a website which should actually not be in the data. But Philip will now go more into detail for some of the COVID topics, I think.
As you see, topic modeling generates lists of words, and we as linguists are forced to do a coding. And you can do this by your own, but you can do this in a team. And then we as humans see in this lists of words maybe a topic. For example, topic 7 is the COVID-19 situation report. So death, country, infection number, million, rise, high. This is quite distinct. And the topic 8 could be coded as testing. It's about hospital testing, patient, test positive, and so on. And topic 11 could be coded as vaccine and vaccination. It's about dose, receive, shot, Pfizer, booster, and so on. And the last one that we chose here for demonstration reasons is, well, I can't see because there's this bar from Zoom, but it should be about measures. Yeah,
behavior measures.
13. So this is the idea about topic modeling to use for a research question, to use it for qualitative interpretation, and to get an idea of what topic or aboutness could be. So the final example is finding concepts. So the research question is, we want to find concepts of a very abstract word, sustainability, or distance, or personal responsibility. So we do not start from a semasiological perspective. So we have an expression and we are interested in the meaning or the concept. But we have an onomasiological perspective. So we started from the idea of a concept, but we are still working with the surface of language. So computational linguistics is always about the surface. We are only able to count what we see, what we have in the data, but we can use a linguistic trick. So we ask, why are, for example, huge, big, massive, and great either more or less synonyms? And we can argue because they can be used in similar contexts. And then we can argue that different words used in similar context have some similar concept or meaning or semantical or pragmatic function in common. And with this trick, we are able to find concepts. And this has to do a little bit with mathematics, but Klaus will explain.
Yeah, we use word embeddings here, or that's what I'm going to talk about. And again, this is a very superficial introduction. Word embeddings have a history of over 30 years now, probably, even though they were called word space models until about 10 years ago. They actually have some linguistic foundation in American distributionalism, which is why the quote by John Firth must never be missing. He said, "You shall know a word by the company it keeps," though his notion of company was probably a bit more complex. the idea can be operationalized computationally very efficient by defining company as a fixed size of a fixed sized window of words around a focus word. So you simply scan through a text collection and count the number of times words co-occur within, for example, 5 words to the left and the right. What you get is a matrix like the one you see here. So, for example, the word bike never occurred with byte. It has a 0 entry in the first column, and but it occurred 9 times with by, whereas lion occurred 6 times with byte. But buying is obviously not a thing you do with lions. This matrix can be interpreted as a geometric representation of the lexicon within an n-dimensional space. So each word, each lexicon entry is assigned a vector with n dimensions. For 3 dimensions, the figure on the right gives an example. The arrows represent words, vectors for individual words, and the axis would correspond to if we stick to this example, to the names, to the words at the column indexes, so byte, by, drive. In reality, a number of mathematical operations are applied first, and the axes represent not just the word, but rather uninterpretable semantic dimensions. The results are superior, though, with these broader dimensions, and they are much easier to handle because their dimensionality is much smaller. If you have a large corpus and you really took words as the dimensions, that could be millions, and with the compressed representations, usually the dimensionality is about 100 or so. The geometric representation allows to perform standard mathematical operations within this higher dimensional space, and therefore to do computations with words. For example, in the figure on the right, still, we could measure the angle between the cat and the dog vector. Can you show the next slide? Yeah, and we could compare it to the angle between the cat and the car vector, and obviously the angle between cat and dog is very much smaller, which of course corresponds to our intuition. If you systematically compute all distances, all such distances or angles, you can determine the nearest neighbors of a word, and Philip will present that on the following slides.
Maybe now it's time to switch to the workbench.
Should we maybe ask first if there are questions up to now? Because in the chat very early a question occurred, which was related just generally to the SwissAL data workbench. Can I use the SwissAL for data on journalistic articles? Maybe you can briefly just comment on that.
Yes and no. You haven't access to the full texts due to legal reasons. So data protection, and on the other side, you can use the public workbench and can do all kinds of distant reading analysis, also with journalistic texts. They are from Switzerland, in especially German, French, and Italian.
Okay, thank you.
If you have any questions, don't hesitate to post or to ask. You see this public workbench here, and it's possible to click here on TensorBoard, and then you will see this very interesting blue cloud, also used for a chilling evening. And this is the English Corona corpus that Klaus mentioned. So you choose a corpus on the left, and then you search for a word. For example, the word huge. And if the word embedding works, we should see words that appear in similar contexts. So we are able to see a kind of functional synonyms in a way. And it works, as we can see here. If we isolate 101 points, it was wrong. Sorry.
When you stop it, the labels disappear for some strange reason.
So working for huge. And we see the nearest neighbors in the list on the right-hand side. So we see massive, enormous, significant, big, great, and so on, colossal. So some of the words that we think that it should be shown up, we search for huge. And we want to see, starting with our research question, we are interested in the concept of sustainability. We see words that are nearest neighbors in this mathematical sense of nearest neighbors. And we see words that are similar used as sustainability are environmental sustainability or ESG, circularity, environmental stewardship, nature-based solution, low carbon, carbon footprint. So we get an impression of what is sustainability about. Seems to be about environment, about a specific kind of economy. And so we are able to build this concept of sustainability, and we are not sticked on the word sustainability. So this very powerful tool can be used for free when you choose the workbench and click here the TensorBoard and choose a specific corpus. If there aren't any questions concerning this blue cloud now, I will go back to the slides.
Well, there is one question here I think we could answer right now. The question from Jean-Paul Bernjung. How can we use this tool to analyze data from indigenous languages?
Well, in principle, the algorithm is completely language agnostic, so you can feed it with any language data. But of course, you need quite an amount of language data. A million words would not be enough. So probably getting hands-on enough data will be the difficult part. Putting it into a word embedding is not a problem, but yeah, with languages where you only have sparse data, you probably have a problem. There are more modern approaches, context-sensitive models like BERT, and they offer some techniques to adapt language models from related languages with smaller amounts of data in a new language, in a new but related language. So that might be a possibility to, at least you could try to do something like that.
Maybe we can put the link to BERT. It's from Google, I think, in the chat.
Yep.
Did that answer your question, Jean-Paul? Okay, I can't hear an answer right now. So maybe I have two more questions here in the chat. One is from Fevzudina Saracevic. I wondered whether the tools are inseparable from the corpus, and I think in part you answered that one just now, Klaus. That is, whether one can feed and analyze a different corpus, perhaps in a different language, using the tools shown.
Mm-hmm. Actually, if you you can install the TensorBoard software locally, or there are even publicly available instances of TensorBoard, and they have the ability to upload data. So the problem then is that you have to do all the computation before, and then you can upload it just to get the display. But if you manage to do the computations, then even in our instance, you can upload data yourself.
Thank you. I hope that answers the question. And from Vanessa Vanzan, there's a question: can we train the model or use it to map ironic uses or irony? It's a difficult one.
Yeah, that's well, I think with this simple word embedding model, which is not context sensitive, so every instance of a word is accumulated into one vector, you cannot I mean, irony is usually a thing which does not belong to a word, but rather to syntagmatic construction. So what you would need there is, again, something like BERT, which is context sensitive. So you get a representation for a whole sentence, all the word vectors are somehow combined, and then you can compare sentences, and you might be able to cluster ironic and non-ironic uses. Yeah, but I can't really tell if it would work, but it would maybe be worth a try.
Sometimes we mix this word embedding with collocation analysis. So we search and find for words with the word embedding, and then we look up these words with a collocation, and then you see the real context of each word and can see, is it ironic use or not.
Thank you. Thanks a lot. And Vanessa Vanzan says thank you, and Fevzudina Saracevic as well in the chat. So I think for now the questions are answered, and you may go on with your slides.
Mm-hmm. These are results from a German corpus, and we translated it for you. So we switch to the English version. We still want to find concepts, and you see on the left column the search word distance. So we looked up the word distance in our word embedding model in a COVID-19 corpus, German speaking from Switzerland. And we looked the word distance in a word embedding model up in a corpus from German speaking journalistic media from Germany between 2013 and 2018, so before COVID-19. And what's now interesting about this approach is that we don't look for the lexicographic semantic of the word distance. We are looking up the usage-based semantic of the word and also for the concept. So for example, you see distance is used, as you may remember, during COVID-19. Distance is a hygiene-related concept. So you have to keep distance from each other, 2 meters, there's a safety distance, and so on. These are the nearest neighbors of the word distance in the COVID-19 corpus. And very distinct is the nearest neighbors result in the time period before COVID-19 in the German media. You see, for example, nearest neighbors of distance is grow, distance between, lead, a roll past, far ahead, amount to, front runner. And this is a concept that is or could be interpreted as distance as a concept of competition. So this is about sports, who is the first place from the football table and so on. And the second example is in the line below, the personal responsibility. So we're interested in the concept of personal responsibility, how it's changed between the time before COVID-19 and during COVID-19. And maybe we can interpret this result that during COVID-19, personal responsibility is a social concept. So we have each one, we have stick to rules, we have self-discipline. So this has to do something with a social world. And in contrast, we have this nearest neighbors in the media corpus before COVID-19. And it is not really different, but we have also another aspect. We have personal responsibility between a social concept and also an economical concept. So economic order, for example, social market economy, these are the nearest neighbors in the time between 2013 and 2018. So we see we can use word embeddings also to see specific semantic spaces like COVID and non-COVID. And we see pragmatic and semantic functions that really changed in a society. And this is not sticked to the lexically semantic. So a few last slides, especially regarding example 2 and 3, some limitation. Klaus showed also a topic that is difficult to interpret. So we have to keep in mind that topic modeling generates topics that has to be interpreted against the linguistic backdrop. So we have to understand what is a machine doing. So for example, you see this topic and it is difficult to see what is the topic here. What is the aboutness in this list of words? And as Klaus mentioned, there are also stop words. So we can train the topic modeling that we want to ignore some words, but sometimes it makes sense to put these words in the topic modeling. But the computer will always give us an answer. So remember the number 42, and we are forced to interpret the results and to understand what the computer is doing. And the second limitation concerning the word embedding, the nearest neighbors are often synonyms. However, and this maybe has to do now with the question of ironic usage, sometimes these nearest neighbors are antonyms or hyperonyms and other semantically related words. So we have to understand what the machine is doing in order to do a reasonable interpretation. Well, a short outlook. We will transform the SwissAL-Workbench now into an ORD platform so that it will be easy for everybody, especially for people who are interested in applied science, but have no idea what corpus linguistics is about, to use the data. And we will especially address some challenges, especially the copyright protection law, for example, and data protection, and also to understand how people from outside the linguistic is working with linguistic data. So what do they want to do with, for example, clusters and in terms that are interested. It's noisy now. And the last one, yeah, now we are part of Clarin, and we are really proud of it. And if you like to know what we are doing in the Switzerland part of Clarin, you can keep in touch with us. And if you're interested to keep in touch with us personally, Klaus and me, feel free to write us or to follow us on Twitter. Thank you for your interest.
Yeah, thank you.
Thank you very much for this great tour de force through digital linguistics and the SwissAL data workbench. Yes, the floor is open for questions now. And please, could someone who has his mic or her mic switched on, switch it off when not speaking, because it makes noises for all the rest of us when it's switched on. Thank you. So the floor is open. Questions? So if I don't see any hands raised yet. And Philip just posted the link to the SwissAL workbench where you can have a look and use it as well. So maybe I can start with a question. You mentioned co-occurrence and collocation, and I understand that it is a difference for the way we are changing qualitative and quantitative and quantitative and qualitative research questions, whether we are looking at the co-occurrences and the collocations. Could you maybe explain that a bit more?
I'm not sure if we speak about co-occurrences.
It was mentioned in the beginning,
Okay.
and maybe you could just give an example with regard to pragmatic questions where it makes a difference to look at the co-occurrence versus the collocations.
So prototypical co-occurrence, you look words up in the corpus to see if they appear in the same text, but it depends on it depends on the text, on the form of the text, and also the functions of the text. And if you use collocations, you need only one specific word, and you are interested in a specific window frame, for example, 4 to 3 words on the left and 3 to 4 words on the right. And then you will get the semantic of your word that you looked up, which is very strong connected to the idea of firth that Klaus mentioned. So if you use a collocation, you're interested in the semantic of a specific word that you looked up. And if you are using co-occurrences, you need at least 2 words, and you're interested in, do these 2 words appear in the same text on the statistical level?
Thank you. I think that helps a lot to understand the differences, the different methods you can use when you are looking for something in texts.
Well, this is the way we do it. Maybe, Klaus, you want to add something?
Well, for me, co-occurrence isn't really linguistically grounded. You just take some random entity and say, and look if some 2 things occur within that entity, but there is not really linguistic grounding. Or, I mean, words can co-occur together in a text almost randomly without having any sort of connection. So this is, for me, it's just from information science. It's taken from information science. You just need something you can work with, and so you just take something easy.
So this is rather a data-driven approach.
This is interesting to see that there are approaches that can be done, but we need linguistic, so qualitative research questions. Otherwise, they don't make sense for us. This is, I think it's an important learning.
Thank you. So are there questions now? So Melissa Drie, hello, thank you for the talk. Is there any spoken data corpus? Do you think it would make sense? And I think that ties in with the question regarding indigenous languages as well, which mostly exist in spoken form only. Many languages would need transcription first in order to be put in a data corpus. So maybe you can expand on that.
We do work with transcribed data, but all our tools only support textual data. So we can not really do any analysis on the spoken data. It has to be transcribed somehow, and then our tools are able to process it. Recently, there have been advances in computational methods also in this field. There is the Whisper transcription model from OpenAI, which is supposedly working very good. But again, if you have lesser resourced languages, you have a problem. So, but we cannot actually work with anything but text.
Okay, does that answer your question?
Yes, thank you. But if, for example, I already have my transcript, a big aura of like 80 hours, do you think it could be uploaded and maybe I don't know.
We're currently trying to add functionality to the workbench, which in the end will also allow user upload of data. But at the moment, we can, apart from the word embedding models where you can upload pre-computed stuff, but otherwise we do not offer that.
Thank you.
So it would be possible to upload a corpus of transcribed speech and use the word embedding model?
Only if you do the computation beforehand. So you have to really do the model, and only the visualization would be available from us. So you first have to compute all the vectors for the words, and once you've done that, you can upload it. But that's not really the hard part, I think. The computational expertise comes before, so probably it's not much help.
So that sounds to me that a project of its own is needed to do the computational part. Is that so? Okay. Yeah. So we're still, we still have to wait a bit in order to be able to input spoken language data, which really would be great to be able to do that and to compare spoken language data with written text data as well. Now, are there any more questions? Still have time enough. Look, maybe there are no, I can't see any hands. Maybe we could go back to the topic modeling then. There's a question. I see Katarina Koretsky-Kroll. Are there any books on word embedding or topic modeling that you could recommend?
Sorry, I think I'm the wrong person to ask there. I just read the articles and stuff, but a textbook, I'm short of a reference here.
Is there an article one could read and benefit from, even if we are not computer linguists?
It's hardly to understand what they write.
Okay. So how do you manage? You get everything translated via Klaus.
We have Klaus. Yes, he's a translator for that for us.
Okay, so sorry, but my question was on the topic modeling and the example you showed us from the English corpus. You had these many, you I think made a topic from it that was called political. You have these many uses, I as a voter of, or I as a voter, a former voter of. Does that actually, if that happens to be kind of well, recurring collocation, does that give us a glimpse into patterns of thinking or a specific discourse frame of this British discourse of the time, which is represented in the corpus?
No, we choose this example because these are English data that we can show today for the audience. The idea with these I as, me as, or in German, ich als, came up with this project with the German broadcaster online forum, where the citizens are want to show their expertise in the field, want to show they're concerned. So they have to get a position within the discourse and say, me or I as a teacher have this experience with German television, and therefore I vote for or against this program. And so we just transform, or we just relate this idea of construction to this Facebook comments, but was just an idea of showing English examples. But we have these kind of Facebook comments. So if you are interested in, you can have a look at if there are any interested identities that give us a hint of some political issues.
Thank you. And Klaus posted an excellent low-level introduction to a topic modeling tool with a link you can use.
I mean, there are loads of blog posts on the internet about bird and word embeddings. I can't pick out one, but there is good stuff.
Well, maybe it's the better way to search for something on it by Google in the internet and on YouTube, which is nowadays more and more the preferred medium instead of books or teaching materials. Okay, are there any more questions? Yes. Yes, please.
Yeah, hello.
Hello.
It was very interesting. I wanted to ask, I've already posted the question 2 times in the chat, but I had to get,
I
got a call, and yeah, I had to take the call, and I don't know if it has already been answered, but can I use the data for some sort of data journalistic article? That's what I wanted to ask.
Really?
So you want to write a data journalistic article and want to build, for example, a visualization of some aspects.
Yeah.
This is a very good question. I think from the legal aspect, it's possible, but maybe you can write me an email so I can check this.
Okay, because I thought that data is very interesting for journalistic articles, because you can look, for example, what topic was very important in a certain time period. For example, the Ukrainian war. the Russian invasion, and I thought I could use that for interesting stories. But yeah, I will write you an email when I have more details.
Yeah, thanks.
Thank you.
Okay, so maybe I posed the question in the wrong manner when I asked them before. Sorry. So good that we could talk about it some more.
Actually, as I said, we are currently developing some more features for the software, and one of the features would definitely be to be able to export data frames and even code for visualizations. So you could either just use it as it is, or build your own visualization on top. So that's really one of the most important features we're building in right now. So at some point it will be there. The project runs until the end of next year, so it must be finished by then.
Okay, thank you. And there's a thank you in the chat as well. I don't see any more raised hands.
Can I ask a question to you, Christiane?
Mm-hmm.
What do you think is the relationship between corpus linguistic and pragmatic?
Well, I actually think that the question on irony and also on humor is a very interesting one to be researched with corpus linguistic methods as well. But you would need to identify specific, I don't know, specific patterns or qualitatively, and then search for them quantitatively in the corpus, I think. So, and I think in order to model or operationalize questions like what is ironic use or what is humor, you need to do a lot of qualitative, or need to take into account a lot of qualitative analysis we have in pragmatics actually, and to operationalize them into quantitatively computable questions and algorithms, I think. I don't have a very clear understanding of that, but a kind of vision that there are a lot of options ahead of us.
Yeah, thanks. I think when we want to know what is humor, we started to crawl joke websites and start to work with these data and ask ourselves afterwards what is humor about.
So you would start from the data-driven approach,
Yeah,
collecting data and then asking, now what is humor, and not what has been found in pragmatics. Humor is what works as humor, and then try to tackle it as a quantitative question, quantifiable question.
But we know what we need the work of the qualitative to interpret the results, as we showed. So we have to we need a concept of humor, otherwise we are not able to see anything in the data.
Yes. And I think that's the basic or the baseline really. You need to have concepts in order to be able to form a quantitative research question.
Mm-hmm.
Okay, so some already left us, and maybe this is a natural point of ending we are taking here. And I thank you very, very much, Philip and Klaus, for this insightful talk and the demonstration of how quantitative tools may work in order to find answers to qualitative questions, and how to interpret qualitatively quantitative results. And I think what you've all also shown is that there's still quite a way we have to walk in order to be able to use these tools really efficiently, and there has to be a lot more of research going on about how to operationalize questions in algorithms, and also a lot of reflection on how to translate quantitative results in qualitative answers. So I thank you all of you who were attending, who posed questions, and I hope we will have another webinar in maybe half a year or so. And you will be informed about that by the IPrA team. And if you have any ideas, or you now may think, oh, I have an idea that I would like to know more about this or that method or this or that topic that should be relevant for more people, more researchers, you can write an email to me or to the other colleagues in the team, in the education and outreach team, or to Jeff Bashuren. So just suggesting what would be a good subject for another webinar maybe. And for the time being, thank you very much for your attendance, and I wish you a good weekend, and I hope that for all or most of you, a relaxing summertime will await you. So I hope we will be seeing us in Brussels at the IPrA conference, and if not, we will surely see each other again online in another webinar or at any other point, any other activity from IPrA or some other related topic. So thank you all, and goodbye. Good afternoon.
Ciao.
Goodbye.
Thank you. Bye bye.